If I'm talking about in data science, so SQL, MySQL, MongoDB, data visualization with Power BI, Tableau, and also with the Python, like the some machine learning, generative AI, deep learning, KNN, and some machine learning like bagging and boostings, and the random forest, and the RNN, artificial neural network, and some challenging tasks like the vanishing problems and vanishing grading problems, and also into the deep learning projects like recurrent neural networks and artificial neural network and convolutional neural networks. And along that, if I'm also talking about in hypothesis testing level, so I definitely also use in Python programming using with the stat models and the SciPy library, and along that the R programming language basically. And along that I have also some additional skill related to the full stack basically, like Node.js and the Django. So I also like recently I'm also like providing the training for the USA San Francisco for the professionals related to the data scientist trainings for the remote basically. And I did my masters in computer science in engineering, so it is all about for myself. Thank you.
Okay, that's great, Sachin. Okay. So let's start with the basic machine learning. Can you just pick any one of the machine learning algorithm and explain me from the scratch and make sure you are covering the mathematical formulas and concepts also.
Okay, so if I'm talking about, so the K means algorithm basically. And also I want to choose first of all like the linear regression and the logistics and the polynomial basically. Like if I'm talking about, like I want to basically to classify the data, and also to like with the help of like there is any correlation between the data, yes or no, so we can easily find out with the help of panda like the co-rr. But now the question is that how we can find out some like the linguistic and some probabilitical problems and the relationship basically. So in that situations I mostly use the linear regressions. And but when we want to find out like the hyperplane, the distance between of them, like the linear regression, so on that situation basically I use the SVM, support vector machines, and to find out the distance and to minimize those problems basically to nearby the data point from this the hyperplane line. So I use this kind of the like machine learning library for also to clustering basically the k-means and to classify the data, and to those basically are nearby to this one. So in that situation, the mathematically I use some like the mathematical formulas like to find out the distance, like the distance from the also the sigmoid basically and the ReLU into the recurrent level. So similar, I use some mathematical concept to find out the distance, like those distance are nearby to this one in the machine learning algorithm.
Okay, so just a quick question. So what is vanishing gradient? You mentioned, right? So what is
Yeah.
vanishing gradient and how to solve it?
Yeah, actually, if I'm talking about, we have also the recurrent model, and along that we prefer the LSTM because in LSTM we have the three gates basically. So in that cases, like the LSTM is managing the gradient and to the processing and to the layer basically. So in that situation, the vanishing problem is easily maintained by the LSTM, not by the GPU, because the GPU we have only the two gates.
Okay, so how do you, what is vanishing gradient basically? So how do you solve it?
Yeah, like when we have some uh, gradients like disappear into the layer basically. So if the particulars some gradient basically disappear into the particular layer, so in that particular situations if we want to handle, so in that situation we can use the LSTM, the gate, because in that LSTM we have the three gates to maintain that kind of the problems, the gradient problem basically.
Okay, so again, in neural network, we have something like SGD, ADAM, momentum, right? So what does it mean?
SGDB.
SGD, ADAM optimizer,
Yeah, Adam.
gradient.
Adam, and yeah, the Adam is also like a technique, like whenever I apply some multi layers basically, to classify the data and the image basically. So on that situations like using like the drop and the dance and the dropout and the sequentials. So in that like when I applying the layer, so in that situation the internally I use the relu and also like the sigmoid and also like use the concept which you are discussing.
So what is the purpose of that actually? Why it is used?
The recurrent model.
No. That Adam SGD, why it is used in neural network? So what is the significance of it?
Yeah. So basically, like whenever we are just doing working with the deep learning, so we need so many like computation power requirement basically. So the machine taking so much time, the time and the delay and the callbacks problem basically. So to manage that kind of the like the session and the time management problems and to efficiently to work them, so the Atom will be a more efficient to maintain the size and the timing complexities, the callback problems.
So how Adam improves actually?
Into the model basically. So like whenever we apply to create them, if I'm talking about the CNN, so I make them the particular segment 32 by 32 and 8 and 32 by 32 by 16 and something like that. So after applying all the layer basically now I want to flattening the data. So when we are flattening the data and the neural network basically, so we want to basically to enhance and to for the performance tuning, we want to apply the item basically.
I got it. What does SGD Adam does internally? Can you just explain that?
Has GPT Adam internal.
Yeah, SGD and Adam.
Like after applying so many layers and the classification is not accurate, so if we want to enhance the performance tuning of my classifications, so that on that situation basically I want to use that particular things basically.
Okay. Yeah, okay, Sachin. So can you just explain me the transformer architecture end to end from the scratch? Explain me what is
Yeah.
transformer and how it is
Yeah,
built
like,
architecture. Yeah.
but thank you, thank you. So when we are just want to like take the particular data, so firstly we want to encode and the decode basically, and then give the output. But now the question is that when we are encoding and the decoding the particular data, so there are so many basically the more accuracy and the better way. So I apply so many layers with the help of the sequential dance and the drops and so many like maintaining the scaling also, like if we have a data scaling like the standard scaling and something like that before the process basically when we are just maintaining with the help of a scikit-learn. But now the question is that when we are encoding and the decoding the data, and so on that situation like firstly we just giving taking the input and into the like the architectural, so we are just encoding and we are just decoding with.
So you have any idea what is PCA or single value decomposition?
Yeah. So like principal component, this is a thing like when we are just clustering the data, but now the question is that the data points are like the so far away. So if we want to manage the space on the data sets and on the points basically, so the principal component analysis like that is a great thing, and to maintain the data into the matrix also.
Okay. Can you just explain me what is the loss function for logistic regression?
Yeah, if I'm talking about in the loss functions, like in firstly, I want to explain like the in logistic, we are just maintaining the data 0 and the 1. So suddenly we are maintaining the data like the 0 and the 1s, like those values are not nearby to this 0 and 1. So if you want to like maintain the loss, so the loss accuracy management, this is also the to identify like the data like the boolean basically like up and down.
Okay. Yeah, okay, Sachin. I think I'm done from my end. So anything you want to ask me?
Okay. So, like any suggestion regarding this a short period of time, like Danis sir, if you want to, it is good. And how many like
Uh,
you went to?
yeah, you're good